Hello viewers, you are welcome once again. We are still under logic. Christ the Almighty God's algebra. Today we are going to prove the law of excluded middle in this tutorial. Let us start. Prove the law of excluded middle. P or not P is tautology. We want to prove the law of excluded middle. That's P or not P is tautology. Let's prove this law of excluded middle. Proof. Let P be statements such that P equals P we say that you want to prove the law of excluded middle. You say let P be statement such that P is equal to P. If P is a statement, P is equal to P by identity. P is equal to P. That means P is equal to itself. That is, P is equal to P. Whenever P is true, P is also true. Whenever P is false, P is also false. That's what we mean by P is equal to P. So it's justified by identity. You say by identity. If P is equal to P, it means that P, if and only, it means that P, if and only P is tautology. Because whenever this P is true, then the other P is also true. Vice versa, whenever the later side of the equation is false, also the right hand of answer of equation is also false. We say if and only if and only if P, if and only if P is tautology. Now it has now been transformed to biconditional state meant. Since it's now in form of biconditional statement, and whenever P is true, the other P is also true. If that is the case, it say it's tautology. That's no case we are going to obtain for city because they have the same value throughout. So we can obtain for city. And if that is the case, we say that it is tautology. Now it's being justified by logical equivalent. By logical equivalent. Since whenever the left hand side is true, also the right hand side is also true. If that is the case, we say that we are going to transform it to conditional statement and then say that it's also tautology. You say if and only if P implies P is tautology. That means whenever the left hand side is true, the right hand side also must also be true. You say if that is the case, you say it's also tautology, justified by logical implication. By logical implication. Since P implies P is tautology, that means whenever P is true, also P is also true. If that is the case, you say if and only if P is logical implication of P. If P is, that means P is logical implication of P. See, if and only if P is logical implication of P. You have now derived that P exists. Since P is logical implication of P, it means that P exists. Since now you have now proved that, you have now derived that P exists. Now let us prove the law of excluded middle that P or not P is tautology. Since P exists, we say that if and only if P is equal to P. If and only if that if P exists, it also means that P is equal to P by identity. By identity. Then, since whenever P is true, also P is also true. that P at the right hand side of the equation is true. Also, if it is true, then P at the right hand side of the equation also must also be true. If that is the case, we say that P implies P is tautology. If and only if P implies P is tautology, being justified by the law of implication, or being justified by logical implication. Biological biological implication. Since now we have now derived that P implies P is tautology. Now let us use first educate's law of equivalence to transform it into disjunctive statement. We say if and only if and only if not P, if and only if not P or P. That means by first educate's law, there represent P, while this represents Q. If that is the case, we say that not P or Q. Now you see that you have not P, then P represents Q represents P. We replace Q with P. We then have not P, and we have not P or P is tautology because it is preserved equivalent with P implies P, because P implies P is tautology, and not P or P preserve equivalent. Educate's law preserve equivalence. First educate's law preserves equivalent. That means we say that not P or P is tautology. By first educate's law. By first educate's law. Now we say that if and only if we then commute not P or P, let us interchange it. It still preserve equivalent by law of commutativity. You say if and only if and only if P or not P is tautology by law of commutativity. By law of commutativity. So it preserves equivalence. The law of utility preserve equivalence. Now we then conclude, because we have now proved that P or not P is tautology. We then conclude, we say, therefore, P or not P is tautology. We have now proved the law of excluded middle, that it is true. We have first of all derived that P exists. After we derive that P exists, we prove that P or not P is tautology. So P or not P is tautology, is truth. At this junction, we will draw our curtain. Thank you, viewers.